Okay, so the study that I chose for exercise physiology was short-term sprint interval training versus traditional endurance training, and how they have similar initial adaptations in human skeletal muscle and exercise performance. So endurance training, or ET, which is probably what I'll refer to it as in this presentation, produces several physiological effects that benefit your exercise capacity. An example of this is skeletal muscle substrate metabolism. Opposite of this, you have your high intensity sprint interval training, or SIT, which again I'll refer to as in this presentation. This is usually thought to have less of an effect on muscle oxidative capacity, substrate utilization, and endurance performance. Although it does have its own benefits, such as increasing max activities of mitochondrial enzymes, it reduces your glycogen utilization within your muscles and lactate accumulation. Essentially, overall, it improves aerobic type work. So we see that they both have their own benefits, but furthermore, SIT is more effective than endurance training for improving other important determinants of your endurance performance, such as your muscle buffering capacity, which we'll look at in this as well. So therefore, low volume, the volume is important to consider with this, SIT could equal a time-efficient strategy to induce muscle and performance adaptations like high-volume endurance training. So the purpose of this study that we're looking at, it was to compare changes in exercise capacity, molecular and cellular adaptations in the skeletal muscles after low-volume SIT and high-volume ET. The hypothesis that the author provided was both SIT and ET would increase their muscle oxidative capacity at 750 kilojoule time trials, and they thought this because there's a major contribution from the aerobic metabolism here. And then on the other side of that, they thought that the SIT but not the ET would increase the muscle buffering capacity at the 50 kilojoule time trial performance because there's a large contribution from the non-oxidative metabolism. So the methods, they use 6 sessions for the SIT of breathe repeated all-out 30-second cycling, efforts with a short recovery over a 14-day period, and then the endurance training, there's also 6 sessions of 90 to 120 minute moderate intensity cycling as well, with a 1 to 2 day recovery, so a longer recovery period here for the endurance training. They use 16 healthy active men that compete or complete a recreational sport at least 2 to 3 times a week, and then they randomly assigned 8 to the SIT group and 8 to the ET group. So they had the pre-experimental procedure for the methods and then also the experimental protocol. For pre-experiment, that just included some testing for them to get used to the laboratory setting and the type of tests that they'd be doing prior to the actual experimental protocol. They tested for VO2 max. They went over the 50 kilojoule and 750 kilojoule time trial performances. Furthermore, the SIT did a familiarization Wingate test, and ET did a submaximal exercise test to determine workload that elicited about a 65% VO2 peak. The experimental protocol included a baseline testing where they did a muscle needle biopsy test of the vastus lateralis muscle. Again, they did the 50 kilojoule cycling test and the 750 kilojoule cycling test. And they used certain time increments after that needle biopsy for both of those. Training then began about 2 days after that. Post-training, they did another biopsy test to once again look at the muscles after their training, and then they did a muscle analysis of those samples that consisted of enzyme activity, a Western blotting test, RNA extraction, reverse transcription, muscle buffering capacity, and muscle glycogen. These are just tables that I took from the study that go into further detail of the experimental protocol and the subject characteristics. So results. So for the 750 kilojoule time trial cycling performance, Specifically, the time required to complete that decreased in both groups. It was 10.1% and 7.5% for SIT and ET respectively, but with no major difference between groups. And then also they had an increase in the mean power output from 212 to 234 watts for SIT, and then 199 to 212 watts for ET. We saw similar adaptations here in the 50 kilojoule test. Not as large of increases and decreases, but still the same thing. You had the decrease in time and the increase in the mean power output. So then looking at our muscle analysis here, we looked at muscle oxidative capacity. So the max activity increased after training, but there was, again, no difference between groups. Training-induced increase in protein contents, but again, no difference between the groups. And then the mRNA was unchanged. And then with muscle buffering capacity, that increased after training as well by 7.6 and 4.2 for SIT and ET respectively. No difference between groups. The muscle glycogen increased after training by 28 and 17% for SIT and ET with no difference between groups. So for the discussion, basically the major finding of the study was that 6 sessions of either the low intensity sprint interval training or traditional high intensity endurance training induce similar adaptations or improvements in your muscle oxidative capacity, the muscle buffering capacity, and overall exercise performance. This was the first study of its kind to directly compare the interval versus continuous training using this research design that matched groups with respect to exercise type, so like your cycling, the training frequency, which they used 3 times per week, and the training duration, which was overall total of 2 weeks. But they still differed in terms of the total training volume used for each and the time commitment. Obviously the endurance training was longer. Also, this was the first study to demonstrate that SIT is indeed a very time-efficient training strategy and implicates the same type of adaptations. And this also was a study, one of the first studies to compare the changes specifically in the muscle oxidative capacity after low-volume SIT and high-volume ET. The limitations of this study include essentially this shouldn't be presented as a way or interpreted as a way to suggest that SIT is adequate to prepare for endurance training type activities or sports. Also, the duration of this as a whole was only 6 weeks, and essentially that is a short time period to really see the adaptations of endurance training that could have taken a lot longer. So the study should have been longer to show for that. And then they only looked at what they considered a few muscle parameters. There was a lot more that they could have looked at, and therefore was a limitation concluding the study.